In structural design, critical load combinations are those that result in the highest stresses or forces within a structure, potentially leading to failure. These combinations typically involve the simultaneous application of different types of loads, such as dead load, live load, wind load, and seismic load, in various proportions, as specified by building codes and standards. Engineers use these combinations to ensure structures can withstand the most demanding conditions they might encounter during their lifespan. Here's a breakdown of why these combinations are critical and how they are used. 1. Defining critical load combinations. Dead load, DL. The weight of the structure itself, including permanent fixtures. Live load, LL. Movable loads like people, furniture, and equipment. Wind load, WL. Forces exerted by wind pressure on the structure. Seismic load, EL. Forces generated by earthquakes. Other loads. Snow load, rain load, temperature effects, and more, depending on the location and type of structure. Load combinations. These are mathematical equations that combine the different loads with appropriate factors to represent various scenarios. For example, a common combination might be 1.2D plus 1.6L plus 0.5 LER or S, where D is dead load, L is live load, and S is snow load. 2. Why load combinations? Matter, safety. Load combinations are used to ensure the structure can withstand the most extreme loads it might experience, preventing collapse or damage. Performance. They help engineers design for a range of conditions, ensuring the structure performs as intended under various loads. Durability. By considering different load scenarios, engineers can design structures that are more resilient and have a longer lifespan. 3. How load combinations are used. Structural analysis. Engineers use load combinations in structural analysis software to determine the stresses, strains, and deflections within the structure. Design. Based on the analysis results, engineers select appropriate materials, sizes, and connections to ensure the structure can safely resist the applied loads. 4. Examples of critical load combinations. Dead load plus live load. This is a fundamental combination representing the weight of the structure plus the typical occupancy loads. Dead load plus live load plus wind load. This combination is crucial for structures in windy areas, accounting for both the static weight and the dynamic wind pressure. Dead load plus live load plus seismic load. This is essential for structures in earthquake-prone regions, considering the forces generated by ground shaking. 5. Codes and standards. ASC. 7. The American Society of Civil Engineers, ASCE, provides minimum design loads for buildings and other structures. Eurocode 0, European Standard for the Basis of Structural Design. IBC, International Building Code, which often references ASCE 7. By carefully considering these load combinations and applying them in the design process, engineers can create safe, durable, and reliable structures.